And so I was just wondering, on that side of things, are there any unique design or processing challenges with this material for use in the food industry?
The food industry, part of the safety side, well, food safety is one of it because people put stuff in their mouth, so it has different requirement. Another side is automotive has very critical mechanical requirement. It will tell you exactly this is the mechanical property we need, and you have the specification, you need to meet that specification. For food industry, a lot of our customer, they
Hello, everyone. Welcome back to the It's Material World podcast. This is our very first episode of 2023. Since the last episode, I think I've seen David twice already in person after it being maybe like a year and a half before we saw each other before Barcelona. So I kind of know how things are going for you, David, but uh, can you tell the audience what you've been up to?
Oh, sure. Yeah, it sounds weird to say 2023 already.
I know.
But yeah, no, it's been going pretty busy over here. I'm actually in the midst of a move. I'm moving out to California to start a new job. And so yeah, I'm sure if anybody has ever moved across the country or even from different states, it's quite the hassle. So it's been a lot of planning, a bunch of calling to make sure I have a place to live when I get out there.
Oh my
And
gosh.
just getting back to the swing of it after I took a nice little break after graduating. So all in
Yeah.
all, good start. Just very busy to make sure that I'm not out on the street when I
Did
land.
did you know that Connor's moving too? He's moving to Idaho, and he is basically, since he's out and about, like he's enjoying his time off before he starts a new role. He is out of state, but he has asked me to basically be the person that gives the moving company or whatever the key to his like storage with all his stuff. And apparently, like they are, I don't know, behind the times. I think the whole industry is behind the times because I have to go there and not just drop off the key and be like, all right, cool, I'm done. But apparently I have to stay there for like 5 hours while they
And
finish
just watch
all the
them.
apparently I have to go to, like, I can hang out in the office with Wi-Fi, but apparently I have to be there if there's any questions. I was like, why can't you just FaceTime Connor and ask those questions? Like, what am I supposed to do? But
Um,
alas, we'll figure it out.
yeah, that is the good benefit. I have literally nothing of value, so I'm moving out in some suitcases, so don't need to worry
Nice.
about that yet. But
Yeah, that's what I did. But yeah, so to get into the episode, we're talking about aluminum in a variety of applications. One being, a valuable like a car, right? And the aluminum's use in the car body, how you design different car bodies, doors, for example, for different customers, right? Each car is different. And then taking some of those same like processing challenges, design challenges, and seeing how that applies to like the food foils, for example, like food covering and packaging kind of. So yeah, we really talk about a lot in today's episode, but I wanted to see if you had any favorites that you wanted to mention before we get into it.
yeah, I think our guest, Vanessa, did a really good job of going in depth about the things that need to happen for any product to make it mainstream. And so, if you're ever interested in process engineering or other types of engineering and manufacturing, she does a really good job of illuminating like keywords that would be important to know if you are interested in those jobs and what the process kind of looks like, such as like statistical process control, SPCs. And it gives you a lot of food for thought to like kind of delve in more if that's something you're interested in. So I think she did a really good job introducing basically what it's like to be a manufacturing engineer. And then she talked about some really cool technologies.
Nice pun there, food for thought. But I thought what she highlighted, like some of her greatest insights, was also from the career side. What's applicable to our audience might be the different career options within the steel and aluminum industry. She has like 15 years of experience, mixed between the two, and she goes into detail about the roles, manufacturing engineer, product engineer, quality engineer, et cetera, as well as like sales analysts, like a whole breadth of jobs and some of the more common majors that can make an impact there. But she does highlight that it's not just like set in stone, or it's not just isolated to those specific connections. So that's something to stick around and listen to at the end of the episode. So it might give you an idea depending on your background or what might be interesting to you, and give you an idea of something else to explore in addition to the traditional roles. So yeah, without further ado, let's get into the episode.
Meta Material Inc. is a developer of high-performance functional materials and nanocomposites. Meta delivers previously unachievable performance across a range of applications by inventing, designing, developing, and manufacturing sustainable, highly functional materials. Meta is a fast-growing company with a positive and committed work culture and a phenomenally talented workforce. Our employees are inspired to do exceptional and innovative work and are proud to contribute to the success of the company, and they are our greatest asset. Meta attracts people from all countries and cultures, with over 35 spoken languages represented across all our teams. Meta believes that diversity drives creativity and innovation. With locations in Canada, the United States, the UK, and Greece, Meta is growing and is looking for new talented people to join the team. If you're passionate about doing your best work, making a difference, and having fun while doing it, apply to one of our open positions at metamaterial.com/careers.
Hello, everyone. Happy New Year. So for today's episode, we are very excited to welcome Vanessa Li, current program manager for advanced technologies at Novelis. Since earning her bachelor's degree in metallurgical engineering from the University of Illinois, Urbana-Champaign, and her MBA from Indiana University, she has over 15 years of steel and aluminum manufacturing experience, with particular experience in process, product, and quality. Thank you so much for joining us today, Vanessa.
Thank you for having me.
Great. Well, thank you again for joining us. And to start off, why don't you tell us a bit about what Novelis does as a whole, and then what your role in the company is?
Yeah, so Novelis is a global manufacturing company, and we focus on flat roll aluminum product. Most of our customer base are automotive, aerospace, electronic, beverage can, food container, appliance, and more. We have 33 manufacturing locations and over 12,000 employees. We are the world's largest recycler of aluminum, and we recycle more than 80 billion beverage cans each year. A beverage can be recycled in as little as 60 days. And my role currently with Novelis, I am a program manager in advanced technologies in global research and technology. So our team focus on developing new technologies that eventually will go into production. That is the goal, and better serve our customer base based on their needs.
That's awesome. And so before we get into the many applications of Novelis, so you've been with this company for about 8 years. I was wondering if you could touch on that, your professional career, your professional track from being a quality engineer to becoming a program manager. It's something that I think we haven't really gotten quite into throughout our podcast. Usually a lot of our guests go through the technical track, but there is alternatives for engineers. So I was wondering if you could talk more about your career path.
Yeah, so to begin with, I started my career in steel manufacturing. I have been working in process and quality at the hot dip galvanizing lines for 10 years before I switched to aluminum and joined Novelis. So, in a nutshell, the transition was not easy at all because after you've been working on a certain production line or technology for 10 years, it is hard for me to convince myself to get out of my comfort zone. At the time, I had a good mentor. He basically encouraged me to try something new. He pretty much told me that I will be successful no matter where I go. And that actually helped give me more confidence in trying something different. I guess it is very important to keep an open mind to explore different areas and continue to learn new skills because you want to continue to learn. Everybody is learning. You don't want to fall behind. And
Mm.
so when I was in steel industry, some of the things that I work on in a really quick summary include chemical, mechanical testing in the lab, inspection of products, process improvement, statistical analysis. We evaluate data based on our process and see if there's any trend and how we can improve it. Productivity is very important. Also focus on customer claims, any customer complaint, explaining to our customer what type of product we have based on what they need. You listen to the customer on what they need and then recommend a solution. Also, any quality issue, sometimes we have to travel to customer site and provide service and on-site support. If we are developing a new product, we need to make sure that we follow through and run through qualification trials. So those are in a nutshell what I was doing back in steel. It was particularly for the hot dip galvanizing line, which we bring cold roll steel substrate. It's also flat roll, and the galvanizing line will coat zinc on top of the substrate. At first, I was very afraid that if I try something new, I would fail. But at some point in time, I felt like if I don't try something new now, am I gonna retire doing the same thing for like 40 some years? Probably not. It is good for me to at least give it a try. So after talking with several people, some people will tell you not to try something new, but stay where you are. Some people will say you should try something. I wanted to transfer to the hot mill department, also within the steel company. However, I was told at the time that the business needs me in the hot dip galvanizing line, and they didn't allow me to work on cross-departmental projects. So after struggling for a couple of years, I decided that I really need to continue to grow. So I decided to look outside. That's how I joined Novelis. And I started in our Novi office, which is in Detroit. At the time, I travel a lot, visiting our toll processor, our customer, and pretty much provide support because, Detroit, basically most of our automotive customer are located there. I would say there are a lot of transferable skill. The technology is new to me because it is aluminum, but talking with customer, recommending solution, problem solving, provide corrective actions, and statistical control on the process side, those are transferable skill. So it kind of helped me bridge to the new role. For sure, every time you get a new role, it is easier if you can find some type of bridge that you can link. I worked there for about 2 years. There is a role in Terre Haute, Indiana, which is our plant that manufacture foil aluminum. Pretty much household foil and food containers foil, where we send the foil to our customer and they will stamp into pipe pan, turkey roaster, and so on. In that role, I also use a lot of similar skill. Basically, we want to increase productivity, talking with customer. A lot of our customer may not be very technical, so we, as metallurgists, you educate your customer on what the different type of product you have, the different alloy, the different temper, and if they need something that whether we can tailor towards what they need. So transferable skill is very important. I actually did not plan or think about moving to project management or program management. It was kind of introduced to me after talking with someone. They told me that the company is expanding and this project, they are needing more people to join the team. And what happened was I talked to a couple of people who actually have background in project management, asking them how they like their job, what it is all about. And of course, I felt like, is this something that I will be successful because it's another new area to me. And I guess talking with people actually helped. And I accepted the role and tried something new. So I have been in this role now for 1 year and I learned a lot.
Awesome. Can you go into a little bit like what those differences are now in your manager role and how that varies from the typical engineering track?
I would say as an engineer, you work on problem solving, you work on the technical side. And when I get to Terre Haute, I manage a group of process engineer. And so it wasn't entirely just the technical side, but also how to influence people. At the time, I have direct report, but in project management, the team of people you work with, they don't always report to you. So it's another skill set that you acquire over time, how to influence people without having the authority. Very important part is communication, teamwork, conflict resolution. It's just something that I read a lot. I like to listen to webinar and talk to people, and mentoring is very important to just to be open-minded and get idea on how to tackle a certain problem. For example, if if two people in your team have conflict and it leads to the project is not progressing, as a project manager, you are responsible for the outcome of the project, but solving people problem is also a part of it. So when there's different issue, like how do you tackle this is focusing more on the soft skill in addition to the technical skill. Because if you imagine you have a team of people, you probably have enough technical knowledge within your team. You don't need to be an expert in every single detail. You just need to know how to better manage the human resource around you.
I guess my last question before we move on to your work is, as an engineer, I feel we all have a very we get to see the change we make personally. We get to see, oh, I changed this factor and this is the result. I'm progressing towards the task. But as a program manager, you really take a step back, and it's more about you can have a larger effect on a program without having to do some of the work and seeing it individually. I guess from both sides, how do you maintain like your drive and initiative? Because I feel like as an engineer, it's very easy. I see this change and we get like 10% better X. How do you maintain that kind of drive as a program manager when those results aren't as tangible?
So we have goals, like we have a certain, for example, we are running qualification trials. We have a certain timeline, such as by this time we should be running at this speed on this alloy. By
Mhm.
that time, we should be engaging this part of the line to do whatever. We list out those timeline and share with everybody, and everybody understand what we're trying to accomplish. We also have to report to our stakeholders, such as the senior management, on, if in case there's any delay, why there's any delay. I also manage the budget of the project. So we do have like goals and guideline on what we should achieve. And also we have like quarterly review. We review the project outcome with everybody. If we run into issue, my approach is I would share with people and we discuss instead of, try to bury it and pretend nothing happened. Because eventually it will come out as a problem. So we pretty much, I would say there is very quantifiable outcomes when it comes to project management. If we forecast a certain amount of spending and we did not spend, then why? Is it because of any delay?
I thank you for walking us through your journey. I feel like you gave a lot of insight into what happened at each step in your decision making. With all that said, we'd love to dive into some of the technology Novelis works on. And so aluminum, firstly, like you mentioned, is widely used in car bodies to decrease weight while maintaining strength. I imagine all cars are different and each door, et cetera, is different. But could you briefly describe the process of providing individualized solutions for different customers that Novelis has?
Yeah, so the example that I'm gonna give is a pretty public knowledge. It's not really too detailed into the technology, but it applies to all the companies. And for example, like you mentioned about doors. So different customer has different design of doors. And let's just take an example. One customer, they have different requirement for the door inner or door outer. Sometimes you will hear that as exposed or unexposed. So imagine one of the car door. The outside is where you want to make sure there's no scratch, there's no dent. The inside is something that you don't really see because it's covered up by some additional component. And also, so that is a service requirement. Different parts of the car have, different service requirement. They also have mechanical property requirement, which the audience may be familiar with. It could be different due to different shape. When the blank of aluminum goes to a stamping process, based on what type of shape is needed, it determines what type of deep drawing property we need to make. And so the alloy, the temper, how we manufacture contribute to the end result of the mechanical property. Inner and outer also have different requirement because, due to different safety reason, there's a reason why the customer design a structure in a certain way. For example, let's say we are producing a door inner for customer A. Let's say customer A want to switch. Well, let's say customer A has been buying steel for this part and they want to switch to aluminum. It is not a simple process. You can't just switch without any experiment. They go through a very detailed process called PPAP, PPAP. It stands for Production Parts Approval Process. You can also search Wikipedia, and it's a guideline or a process that outline how to demonstrate the engineering design, product specification, and pretty much the car manufacturer like to follow this process. It makes sure that all the requirements are understood by both the supplier and the customer. And also we make sure that all are being approved before we manufacture, mass produce. So this process standardized the part approval process. We and ensure that there's traceability of the different design. They ensure that we have proper documentation because during a development process, we need to make sure everything is documented and we know exactly, what has been changed, what has not been changed, what works at the customer. And we also control the product and process change. So if there's anything changed in the process, we want to capture those. And we want to ensure the conformance to the next level assembly. Like process stability, we want to make sure not just being able to make one part, but consistently be able to make a part that show similar property and not fluctuate back and forth. We use the term SPC, which is Statistical Process Control. And so we need to prove all these to our customer and before we can pretty much qualify the process. And just a nutshell of the different step, when there's a new idea coming out saying, hey, can we make this part using this process? We call it concept design. So people pretty much brainstorm and discuss, and then they will look into the feasibility. Is the production line capable of making those? Are they designed for that? And then we would design to do experiment and run trials. And after, trials usually don't go well the first time, and we continue to revise and continue to run trials until we get to the point where we think, okay, yeah, we can make the product, but how do we make a stable product? So that will be the next step. And we also need to send the material to customer and get customer feedback, whether it works in their process or not. This process pretty much take couple months to sometimes couple years, depending on how complicated it is. And this is just assuming one part being produced in a certain process route. So if you want to change, let's say, in a nutshell, you go from one caster to the hot mill number one, to cold mill number one, to coating line number one. And let's say the customer has qualified this process route. If you want to change, let's say instead of producing from hot mill number one, you want it to go through hot mill number two, you have to go through this process again because it's a change. So any process change need to go through this process and get requalified. And this is how we ensure we're giving the best quality product to the customer. So anything that touch the metal is key component. We have to monitor every process change.
So when we talk about these changes, SPCs are very common in process engineering. It's very almost tedious work. Let's say a company is trying to make a new car and you have to create these processes for all these new parts. How long do you just estimate that it would take for like Novelis to go through all these iterations and get the SPC under control to be able to say this is production ready?
So usually for one part, I would say a couple of months to maybe a year or two. But if you think about the entire car, there are so many different parts. The parts that we can see, we can see, but there are a lot of parts that is inside the car that we couldn't see. If you think about, like, maybe I should give an example. So you may see sometimes that people are driving a pickup truck that have rusty bottom with holes, especially in snowy area.
Mhm.
That's because they use cold rolled steel. And cold rolled steel is very easy to get rusted, especially during winter time and there's salt, it actually accelerate the rusting. But nowadays you don't see that many cars, especially the newer type of cars. You don't see this type of rust because a lot of the pickup truck they have switched to galvanized steel, or they have used galvanneal or aluminum. They don't rust as quickly compared to cold rolled steel. And so of course, when companies switch from steel to aluminum, they don't just switch the entire car in one model year. Yeah.
So, Vanessa, I was just curious then, quite a turnaround, especially like this type of industry where there's a lot of standards that need to be met. And like you said, statistical process control, you need to be, yep, you need to ensure high quality each and every time. So I'm just wondering if you have a vision for the next 10 to 20 years of if that distribution of aluminum changes at all, if you see any advent of new materials coming into play in the car industry, or what it kind of looks like from the innovation side in the future.
Personally, I wouldn't speculate what is going to happen in the future, but who knows, maybe there's new material, not metal, maybe composite, you
Yeah.
know. And also, aluminum is a very sustainable material. It can be recycled forever. 1 pound of aluminum can get recycled and 1 pound of aluminum will turn back. So you really don't lose anything as long as everybody recycle it. Don't want to speculate what will happen in 20 years, but I believe that in general, material continue to evolve. It may not be steel or aluminum, it may be something else too.
Absolutely. But you make a great point that sustainability will continue to be a bigger and bigger driver for corporations, not just within the automotive industry, but we're seeing that everywhere. And so now I want to kind of shift paths to the food industry, where Novelis also plays a role. I know one of your sites makes lots of foil for food containers domestically. And so I was just wondering, on that side of things, are there any unique design or processing challenges with this material for use in the food industry?
Yeah, so it's very different supplying to automotive versus the food industry. The food industry, part of the safety side, well, food safety is one of it because people put stuff in their mouth, so it has different requirement. Another side is automotive has very critical mechanical requirement. It will tell you exactly this is the mechanical property we need. And you have the specification, you need to meet that specification. For food industry, they may not specify the mechanical property requirement. So a lot of time we have to explain to them. A lot of them they have never heard of. When they talk about strength, they don't know stress, strain, ductility, brittle. They don't have that concept. So um, It's more like trying to understand what they need to make and then reverse engineer it into those terminology to make sure, yeah, we are able to meet this product. So pretty much understanding the customer and translate it back to a recipe that our production line can understand and know how to produce.
Can you go into that like wax lubrication control in however much detail you can? I don't want to get into that in
Yeah,
proprietary stuff.
it's not anything proprietary. Actually, a lot of times you will hear lubrication or oil. We use wax. So at the very last of the production process, like in a nutshell, you go through hot rolling, cold rolling, and then you go through a lubrication line. In the very last part of the process, before it gets to the customer, is where we apply the wax. There are different type of design on the production line, how you want to apply the wax. Some people use a spray system. Some people have different, you know, electro adhesion type of technology. We want to make sure that, if it's from a spray system, it comes out of the nozzle without any clogging. Imagine you have a flat sheet, like this is the width, and you have nozzle here spraying like a fan shape. You don't want any one of them to clog up, which lead to a streak, like a dry streak. Usually it's top and bottom side, and customer may recommend how the amount of coating they want. So we want to make sure a even distribution.
Awesome. And so you mentioned that before is that sustainability, and what Praneeth nicely put together is that sustainability will be a main driver. So maybe just zooming out a little bit, how do you think from a sustainability and a carbon net like zero side is Novelis going to like you're in just innovate to become more carbon neutral or even completely sustainable?
You can actually go to the Novelis website. They just published a sustainability report. There are a lot of information there, but to summarize, Novelis' ambition is to be the world's leading provider of low carbon, sustainable aluminum solutions that advance our business, industry, and society towards the benefit of a circular economy. So these are public knowledge that is published in the Novelis website. You mentioned about carbon neutral. So Novelis has a goal to be carbon neutral by 2050. For example, we also have small goals such as by 2026, we want to have 30% reduction in carbon dioxide. We also want to have 10% reduction in energy consumption, 10% reduction in water, and 20% reduction in landfill. Also, another goal for our sustainability is to increase representation of minority, such as women. The goal says that by 2025, we want to have 30% of women in leadership roles and 25% of women in technical roles. Currently, they are less than these numbers. It is also published in the sustainability report. But I really like the fact that, the company is driving diversity and inclusion. That way we can continue to share good ideas with everyone and continue to innovate.
That's awesome to see that there's innovation going on while you're tackling it from both ends, which is really cool to see. But inherently, right, like recycling is a core component of Novelis's business. And so I just had a kind of materials related question alongside that recyclability of aluminum. I was just wondering, is there a relationship between the amount of times aluminum is recycled, and does that have any effect on its mechanical properties? Like, is there ever a point where you've recycled it too much and it can't be used anymore?
So aluminum can be recycled indefinitely. So for example, if you put 100 pounds of aluminum in to recycle, it will turn back out 100 pounds, no matter how many times you recycle it. This is assuming that there's no contamination and that you didn't mix up different alloy in the process. If you mix up different alloy, then the mechanical property won't stay the same.
Right.
You are assuming that you have a really strict min and max for each element in your alloy, and you never introduce a different alloy into the mix. then your mechanical property should stay the same. That's my understanding.
So I guess from Novelis's side, aluminum itself, like a Coke can, for example, is almost the poster child of recycling. As companies such as car companies or other more heavy manufacturing starts to incorporate more aluminum into these alloys, is it just a area of where you need to confine and we just need really robust recycling systems to separate everything out? Or will they have to undergo different recycling processes where we can make sure they're just as efficient as straight aluminum?
Yeah, so our customer actually have to segregate the alloy. So for automotive, we have closed loop recycling. For aluminum, beverage can is pretty much a very similar alloy, no matter what company make the material. But for automotive, there are a lot of different alloy being made. So yes, it is separated. Like for example, I'll give you an example of closed loop recycling. Some of our automotive customer have agreement or a program with Novelis where, for example, you ship them some blanks and they stamp out the blanks into a car door. Then you know that the window is a cutout part. Just imagine you're making a cookie and you stamp on it, and there's always the side edge, something in the middle that got into a scrap. So our toller, our customer, they segregate the scrap into different bin based on the alloy. And they work with our supply chain or logistics to close loop bring these material back to our facility. So it is very close. Similarly, for food container foil, we do the same thing too. We also segregate all of our alloy in our production process. Our customer also do the same. Sometimes if our customer send a coil back to us as a claim, and if they label the alloy wrong and we put in our process, it could lead to problem because if you put it back in the remelt, then the operator will notice, hey, alloy composition doesn't make sense there. This may not be what you say it is, but we do have a robust system on segregating the different alloy, and this make closed loop recycling to be possible.
That's interesting that there are those processes inherently where that material science knowledge or just that ability to notice, oh, this composition looks a little bit different, how that can, you can maybe tell that something's up with that and then investigate it further. But before we get into the last section of the episode.
You know what? I thought of something fun to share too.
Okay, go for it.
So you would imagine that we can bring in a empty beverage can and bring to work and just toss it in the recycle bin? No, we are not allowed to bring any beverage can to work because if you bring in beverage can to work and if someone just toss it in the process without drying it and then it goes to remelt, it can lead to explosion. So for safety reason, we are not allowed to bring any disposable container.
Wow.
We are not allowed to bring aluminum on site to recycle. It has to go through the required recycle process, like those recycle facility.
Wow. That's fascinating. I would not have pictured that, just even the lack of drying, how that might lead to catastrophic failure. That's crazy. Oh my gosh. So I guess to maybe wrap up this episode, since we've talked about a lot of different applications from the food industry to car bodies, and there's even similarities from the processing side. For any student who might be interested in looking at or interested in pursuing a career in steel or aluminum manufacturing, what options are out there? I know that general engineering knowledge plays a huge role, and it can lead to a bunch of different pathways. David is in cell manufacturing, process engineering, and I've ended up in more of a design assurance engineering role. So I just wanted to hear is that similar? Like what does that look like in your industry?
So I can give couple example, but this may not be a comprehensive list. These are just people that I have worked with, and I try to compile a list. So to me, it doesn't matter what type of engineering concentration you are. What's more important as a junior engineer is your ability to learn and work with people and keep an open mind. But so the example that I'm gonna give are just what people typically go into. It doesn't mean that if you don't have that degree, you cannot do that job. And so process engineer, product engineer, quality engineer, or technical development engineer, they typically have materials, chemical or industrial engineering degree. They work with the process, they work with the product, and they deal with customer. These are the popular degree, but I have seen a lot of people with different background may not even have engineering degree. They ended up doing that. So of course there are a lot of different pathway to get to it. We also like I work with sales analysts, technical service, field service engineer. A lot of them have business degree, materials engineering degree, and chemical engineering. We also have like research and development engineer or scientist, process development or product development engineer. A lot of popular degrees are chemical, mechanical, and material science. We also work a lot with automation engineer because in the production facility, you have what we call HMI, which is the machine tell, like the person need to tell the machine what to do. Popular degree for automation engineers are electrical engineering, not too many from computer science, but more on electrical engineering. Also, in a manufacturing facility, you need to have maintenance and reliability. So, mechanical engineer, electrical engineer, reliability engineers, they maintain the facility, they maintain the equipment, they do budget in case of any new equipment or modification. They also review and advise on equipment design and specification. They supervise the installation and commissioning of any new machine. Also, we work a lot with supply chain. So supply chain analysts, a lot of them have industrial engineering, system engineering, or business background. So you may be surprised that a lot of the supply chain colleagues that I work with, they don't come from supply chain degree. They come from engineering degree. So there are a lot of different pathway you can choose and never stop to explore. Nowadays it's really good that you can look up people's LinkedIn if you think that, oh, this person moved from this degree to this role to that role, and then now he's in this role. You can approach them by saying, hey, do you mind telling me your story? How did you get to that? I want to get some inspiration. Usually people are happy to share with you what they accomplish. And so be willing to keep an open mind and learn about people pathway, give you some inspiration. Even if it's something that you don't want to do, at least you find out it is possible. And just keep in mind that teamwork and willingness to learn, communicate with people, learn how to present the same message to different audience is very important because you will need to at some point present your ideas, and not everybody's are engineers. So if you are trying to present your ideas to someone higher up or someone in business, they may not care too much about the technical side. They just want to understand, the general or the business side. So how do you change your approach when you present based on the audience? How do you problem solve? When you are presented a problem, you want to come up with solution. You don't want to bring more problem to the team. And so, technical knowledge can be learned through your work experience. Nobody expect a fresh graduate to have all the technical knowledge. So never stop exploring. The story will let you know what is possible. When I finished school, I didn't really have, okay, this is the job title that I want. It's more like they just placed me at the galvanizing line. I had no clue what it was about, but I learned from there, and then I learned about the process before galvanizing. I learned about the customer, which is downstream, and then you just continue to explore what is available to you. And I would say even for now, I'm exploring because I never thought about project management. Now I'm doing project management. Would I stay in project management for the next 20, 30 years? I don't know. It really depends on, the time and the timing, the people you meet, and what is presented to you. If someone asks you to try something new, don't say no right away, but try to understand more and explore.
I love that. Yeah, the most growth happens outside of your comfort zone. So it's very evident that you've consistently taken that advice and continued to escape your comfort zone, and your accomplishments kind of reflect that personal and professional growth. So thank you so much, Vanessa, for joining us today. It was an absolute blast discussing all things aluminum and all things Novelis with you.
Thank you so much for having me.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.